In question number 26, the total energy of a particle executing SHM is 80 joule. What is the kinetic energy of the particle when it is at a distance of 3 by 4th of amplitude from the mean position? So we know that total energy is equal to kinetic energy plus potential energy. So total energy of SHM is given by half k into a square, that is equal to kinetic energy plus potential energy, and potential energy is half k x square, where x is 3 by 4 of a whole square. So if I solve this, the value of kinetic energy comes out to be 7 by 16 into half k into a square, and the value of half k into a square is given, that is 80. So on solving, it comes out to be 35 joule. So option 2 is the correct answer. Let's move to question number 27. In question number 27, a spring of negligible mass, natural length L, has a spring constant K. The spring hangs from roof with mass M1 and M2 as shown in the figure. If the mass M2 is gently removed, then the mass M1 is just able to bounce back up to point of its natural length. The system is initially in equilibrium. The ratio M2 by M1 is equal to. So if I see the extension from the natural length, then in this equilibrium position, it can be written as M1 plus M2 into G by K. So if mass M2 is removed gently, then the extension from the natural position will be M1G by K. So it comes out to be M2G by K. It means, suppose if this is the mean position or equilibrium position, then when M2 is removed, the block moves to this position, and this will be M2G by K. But the block stops at the natural position of the spring. So the natural position of the spring is someone here, and this separation is M1G by K. Since from the mean position these two amplitude must be equal, so we can say that M1 must be equal to M2, or the ratio M2 by M1 is equal to 1. So option 1 is the correct answer. Let's move to question number 28. In question number 28, a wire under tension vibrates with a fundamental frequency of 450 Hz. If the length of the wire is doubled, the radius is halved, and the wire is made to vibrate under 1/9 of the original tension, then the fundamental frequency will becomes. So we know that in the case of the stretched string, the fundamental frequency is given by V by 2L, or it is equal to 1 upon 2L into under root T by mu, where mu can be written as density into cross-sectional area, that is pi r square. So from here we can see that F is proportional to root T upon L into R. So if I take the ratio F1 by F2, then it is equal to, length is doubled, so 2L1 by L1, radius is halved, so R1 by 2 divided by R1, and the tension is 1/9 of the original tension. So this is T1 divided by T1 by 9. So from here, the value of F2 comes out to be F1 by 3, and the value of F1 is 450 by 3. So it comes out to be 150 Hertz. So correct. So option 2 is the correct answer. Let's move to question number 29. In question number 29, a block at the end of a spring executes simple harmonic motion with a period T1, while the corresponding period with another spring is T2. If the period of oscillation with two springs in parallel is T, then T is. So we know that in case of a spring block system, time period T is given by 2 pi under root M by K, or we can say that K is equal to 4 pi square M by T square, where T is the time period. So in case of first spring, it can be written as 4 pi square into M by T1 square, and in case of second spring, whose spring constant is K2, it can be written as 4 pi square into m divided by T2 square. Now, when the springs are connected in parallel, the time period capital T can be written as 2 pi under root m by k, where k is k1 plus k2. So if I find out the value of k1 plus k2 from here and substitute here, so this is equal to 2 pi into under root m divided by k1 plus k2 can be written as 4 pi square into m into 1 by t1 square plus 1 by t2 square. So if I solve this, I will get 1 by t1 square plus 1 by t2 square is equal to 1 by t square. So if I check the options, then option 4 is correct answer. Let's move to question number 30. In question number 30, intensity of sound after passing through a slab decreases by 20%. On passing through two such slabs, the intensity will decrease by. So the intensity after passing through first slab will become 0.8 into I naught. So if this intensity passes through second slab, then the intensity which passes through the second slab is 0.8 of 0.8 I naught. So it becomes 0.64 I naught. So this is the remaining intensity after passing through two slabs. So the intensity decreases by 36%. So option 1 is the correct answer. By this, I wish you all the best for your preparation. Have a good luck. Thank you.